Audio Jungle. Audio Jungle.
So now coming to the switching characteristics of SCR. These are switching characteristics. Anode voltage variation, anode current variation. We know that SCR is a semi-controlled. We need to give control signal or gate signal to turn on the SCR device. So when you give the control signal or gate signal to the gate cathode of SCR, the variations of voltage and current are not instantaneous. At what condition voltage current variations are instantaneous? When device is in ideal mode. But all the devices are practical, definitely the voltage and current variations are gradual instead of instantaneous. That is why voltage gradually reduces and reaches to its on state drop, and anode current reaches to its finally steady state current IS. Let it take. This is the on state voltage, V on state. So the voltage is a gradual decrease, current is a gradual increase. The time required to get anode current to final value, anode voltage to minimum voltage drop is called turn on time of the SCR device. This turn on time is given by the manufacturer. Means this is fixed. We know the condition to proper turn on, gate pulse width should be greater than this turn on time for proper turn on of SCR. Otherwise it cannot be found. Fine. Once SCR comes to on state, and that means it carries the rated current, and voltage drop is the minimum voltage drop called on state voltage drop. Gate loses its control. It doesn't require any control signal, means that. So now when you remove the control signal, still SCR is in on state. But how it comes to off state? We know when SCR is in on state, it acts as a uncontrolled device, like it behaves like a diode. So how it comes to off state? We need to reduce the anode current here, reduce the anode current to 0. So this is 0. So basically how SCR comes to off state? By using some techniques like a natural commutation or forced commutation to reduce the anode current below holding current. So with the help of any technique, commutation technique, reduce the anode current and to 0, and anode current reaches to 0 at this point. Now when anode current reaches to 0, can we say device is completely off? No. Still device under favorable conduction due to the excess stored charge carriers in the 4 layers or 3 junctions. That is why it cannot be off where anode current reaches to 0, right? But what happens now? We already the voltage is applied reverse voltage across SCR, but still all the junctions are in forward bias. That is why anode current increases in negative direction. When anode current reaches to negative peak, at that instant outer junction J1, J3 start to begin to block the voltage. That is why voltage goes to negative and current decreases. And let it take as T1 and T2 and T3 and T4. At T3 instant, J1, J3 both regain their blocking capability, means they come to reverse bias at T3 instant. But we cannot say SCR is completely turned off again because still J2 is in forward bias at instant T3. That is why we should not give any control signal to the SCR to the device at T3 instant. So what we do? And again remove the excess carrier from the inner junction J2 also. So between the T3 T4 excess carriers will be removed from the inner layer J2, inner junction J2, and T1 to T3 period excess carriers would be removed from the outer 2 junctions J1 and J3. So at T4 instant J2 also come to reverse bias. Now all the junctions are reverse bias, device under blocking capability. Fine. So when you give the forward voltage across the device at T4 instant, now J1, J3 both come to forward bias, J2 reverse bias. Now device in forward blocking state. So at this instant only we can say SCR is completely blocking state, means completely turned off, right? Now at this interval, see when you come, this is a turn off process. When you come to the turn on process is a process during dynamic process during which anode current reaches to final steady state value or voltage drops to its minimum on state voltage. This on time has the three intervals: delay time, rise time and spread time, TD plus TR plus TS. Whereas when you come to the T off has again two intervals, TRR and TGR. T off is equals to TRR plus TGR. What is the TRR? Reverse recovery time, during which excess carriers would be removed from the outer two junctions J1 and J3. What is the TGR? Gate recovery time, during which excess carriers would be removed from inner junction J2. So T on calculation, T off calculation, these two are specified by the manufacturer or fixed values. When you observe check the data sheet of the SCR device, turn off time of the SCR device always greater than turn on time of the device. So normally T off should be greater than T on in all minority carrier devices. So SCR also minority carrier device, fine. Now when you come to the successful turn off of SCR, what is the required condition is a very important in the examinations. What is the condition for successful turn off? TC should be greater than T. You just come to this waveform. This is a TQ. TQ would be calculated between the instant T1 and T4. What is the TC? Between T1 and T5. So always TC should be greater than TQ for successful turn off of SCR device. What is the TC? TC is a circuit turn off time which is provided by the circuit, not at all fixed. TQ is a device turn off time, that is a T off, which is fixed given by the manufacturer, right? So for successful turn off, TC should be always greater than TQ. Very important condition. When you go to the rectifier circuits, load changes. When load go to the inductive load, this condition is very important for successful turn off. Fine. So when you come to the turn off time of the SCR, according to the turn off time, SCRs again two types. If TQ turn off time less than 50 microseconds, the SCR is called as inverter grade SCRs. If TQ greater than 50 microseconds, it is called converter grade SCRs. Basically, inverter grade SCRs are used in inverters and choppers. Converter grade SCRs are used in rectifiers and AC voltage regulators or cycloconverters. Fine. So this is switching characteristics. Now coming to the protection of SCR is another important thing. So how do we protect? When SCR is in a practical application, there must be some abnormal conditions. The device may get affected by these abnormal conditions. So we need to provide protection circuit to protect the SCR from these abnormal conditions. So this is complete protection of SCR. So I have given the numbering. One is, this is used, this is basically is a varistor which is connected across the SCR to protect from over voltages. Coming to the second one, this is overcurrent protecting circuit. Is a series combination of circuit breaker and fuse. This fuse is special type of fuse called fast acting current limiting fuse, which has very low response time. So the series combination of circuit breaker and the fuse in series with the SCR to protect from overcurrents. Now coming to the third one, this is the heat sink. The device must be mounted on heat sink to maintain always junction temperature within the limit. So the heat sink arrangement is used to maintain the junction temperature within the permissible limits or safe limits for reliable operation of the SCR device. So SCR can be protected from high temperature by mounting the device on heat sink. And now coming to the fourth one, this is called a snubber circuit, a series combination of R and a resistor and capacitor connected across the SCR to protect from high dV by dt. And when you come to the inductor L, this is called di by dt inductor, which is always connected in series with the SCR to protect from high di by dt. This dV by dt snubber circuit is called as turn off snubber. Di by dt's inductor is called as turn on snubber. So basically these two are called snubber circuits, turn on snubber, turn off snubber. Is very important in SCR circuit applications. Now sixth one is, this is called a gate protection circuit. Gate also should be protected from some abnormal conditions, over voltage, over current, over voltage, and noise protection and high reverse voltage protection, right? So this is complete protection of the SCR device, both anode as well as gate circuit. Now coming to the problems in the examination, you should focus on the designing of snubber circuit. So when you come to the SCR circuit, this is SCR snubber. This is called RC snubber circuit. This is a turn off snubber to protect from high dV by dt. An inductor is connected in series with the SCR to protect from high di by dt. So combination we can call it as snubber circuit. Is very important in all switching devices. Now there are snubber parameters. So how do we design the snubber parameters? So just let us connect the circuit in one circuit, like this is a load resistor. Let it be the simple circuit, supply voltage. This is a switch. So how do we design the snubber parameters, snubber circuit parameters? So consider the circuit. There is a supply voltage Vs and the switch. This is a switch connected in series with this circuit, and consider this is a load resistor. So this is a circuit. With this we design snubber circuit parameters. So by deriving the relations, we get snubber parameter inductor L is equals to Vs supply voltage by di by dt maximum, and snubber resistor Rs is equals to ratio dV by dt maximum to di by dt maximum. And how do we calculate snubber capacitor? If you know the Rs, we calculate the Cs by using this relation, where zeta is equals to Rs by 2 square root of Cs by L. Zeta is called damping factor. So for basically damping ratio varies between 0 and 1. For optimal case we take zeta is 0.5 to 0.6. So definitely you will give the zeta value in the problem. Based on the zeta value, calculate Cs by using these two, right? So this is the snubber parameter designing circuits. Very important in the examination. Now coming to the thermal protection, we know that high temperature of the device can be protected from heat sink. When you mount the device on heat sink absorbs the heat produced at the junction level and transfer to the ambient. So this is the case. The power loss means heat energy transfers from junction to ambient. So this is the path. This is a Tj. I am representing the nodes with the temperature nodes. With the Tj is the junction temperature, Tc is the case temperature, Ts is the sink temperature, Ta is the ambient temperature. And between the two, there is a theta Jc, theta Cs, theta Sa. So what is meant by theta? Theta is called thermal resistance in degree centigrade per watt. So P is the average power loss in the device, which is transferred from, that is called heat energy transferred from junction to ambient. So the thermal energy transferred from junction to case to sink means thyristor case to heat sink to ambient. So this is the high temperature point, this is the low temperature point. So always heat energy flows from higher temperature point to lower temperature point. So what is the heat energy which is transferring from junction to ambient is P, average power loss in the device. The ratio, the relationship is P average is equals to Tj minus Tc by theta Jc is equals to Tc minus Ts by theta Cs is equals to Ts minus Ta by theta Ac. With this calculation, with this formula, we can calculate average power loss of the device, and also it is equivalent to Tj minus Ta by theta J. This is another important relation to calculate power loss in the device, if you know junction temperatures and thermal resistance.